All right, ladies and gentlemen, today's topic is solving angle problems with algebra. So today in class we did a lot of work with vocabulary, and these two terms, supplementary and complementary angles, should be familiar to you. So what we're going to do tonight is apply algebra concepts like solving equations to geometry topics like supplementary and complementary angles. So a quick review of some of the vocabulary we did in class today. Complementary angles are angles that add up to 90 degrees. Remember, a good trick for this is that C for complementary, if you just add one line, it's a 9, like in 90 degrees. Okay. Next, we have supplementary angles, which are angles that add up to 180 degrees. Another nice trick for this is that if you have the S in supplementary, you can add just one line, like so, and easily have 180 degrees, which is what supplementary angles add up to be. Next, a right angle is an angle that measures 90 degrees, and a straight angle is an angle that measures 180 degrees. So these are connected because if you have two complementary angles that are right next to each other, that are adjacent, well then together they're going to make a right angle. All right, and a straight angle is an angle that measures 180 degrees, which matches up with supplementary angles. So if you have two angles that are supplementary and they are right next to each other, they are going to add up to a total of 180 degrees. They're going to be a straight angle. That's weird. Sorry, guys. My pen just freaked out on me. Okay, so now how do we actually solve angle problems with algebra? What you see here is two angles right next to each other that are on a straight line. You may remember from our vocabulary today that these are called a linear pair, which is simply two adjacent angles that are also supplementary. Our first thing we need to do is determine the angle relationship, and we just talked about that. The angle relationship here is supplementary because the two angles are on a line. I ran out of room, sorry. The two angles are on a line, and together they equal 180 degrees. So step 2 is to set up an equation using this relationship we just found as a guide. So if I know that this angle plus this angle add up to be 180 degrees, I can use that to write an equation. I can say 8x plus 10 added to 2x minus 10, it should equal 180 degrees. All right, so we've set up our equation, and now our third step is to solve for the variable. So this is simply an equation that you have to solve, and you guys have done this. You have to simplify first. So 8x plus 2x gives you 10x. And then I have plus 10 minus 10. Well, those just are going to cancel each other out because they're additive inverses. They just add up to equal 0. And then I have my equal sign equals 180. And then it's just a matter of using a little bit of algebra. We have 10 and x here. They're multiplying, so I have to divide by 10 on both sides. And that gives me x equals 18. So that's step 3. We have found out what our variable equals. Finally, the last thing we have to do is determine the measure of each angle in our diagram. So our first angle is angle ABC, and I'm just going to write that angle ABC. You always use capital letters. And we know from our diagram that that equals 8x plus 10. And now I'm going to substitute my value for x into this equation. So it equals 8 times 18 plus 10. 8 times 18 is 80 plus 64 is 144. And then I just have to add 10. And so finally, my answer for the number of degrees in ABC is 154. So I can write that up here, 154 degrees. That should be a 5. My pen's kind of funky. There we go. And then I can use the same process for angle CBD. I'm going to erase this. You guys shouldn't, but I just need more room to write. So here, erase that. And angle CBD, going from here to here to here, equals 2x minus 10. 2x minus 10. I know that my x is 18, so I can substitute that in. 2 times 18 minus 10 equals 36 minus 10, which gives me 26 degrees. And you can always check yourself here because 154 plus 26 does indeed equal 180 degrees, which it should because these are supplementary angles. All right, let's work through one more example. Step 1, remember, is to determine the angle relationship that you have. And in this case, we have a right angle here. WXZ is a right angle, which means it's 90 degrees. So these two angles are complementary. Next step is to use that angle relationship to write an equation. So with complementary angles, you take these two angles and they add together to equal 90. So I can take my 4x plus 10, add that to 2x plus 20, and it should equal 90 degrees. The third step in solving these angle problems is to solve your equation for your variable. So I have to do some simplifying. 4x plus 2x. When I simplify this, I get 4x plus 2x equals 6x. And then I have 10 plus 20, which is 30. And that should equal 90. Sorry, that's an equal sign, believe it or not. All right, and then I use algebra to solve my equation. So I have my upside down t. And I'm going to subtract 30 from each side, which is going to leave me with 6x equals 60. And then I divide both sides by 6, which should give me x equals 10. All right? The last step of this process is to then find out the measure of each of these angles. So I can write angle WXY equals 4x plus 10. And I can plug in 10 for x because I solved that x equals 10. So 4 times 10 plus 10 gives me 40 plus 10, which should give me 50 degrees. So angle WXY I know is 50 degrees. I'm going to erase that just because I'm running out of room. And then we can find angle YXZ. Angle YXZ, which is simply 2x plus 20 and I know that x is 10. Hopefully you're getting the hang of this and think this isn't too hard at this point. It's just plugging numbers in and solving it, that's all. 2 times 10 is 20, and then plus 20, which gives me 40. So this angle should be 40 degrees, which makes a lot of sense because 50 plus 40 does indeed equal 90 degrees, which is what a complementary angle should do. All right, guys, so your reflection today, you need to determine the value for x and the degree measures of angle ABC and CBD. I don't need to see all your work in Edmodo, but I do need to see it on your paper, so make sure you're showing me that. And I look forward to seeing your responses. Have a good day.